Part 3 of Exponents and Surds. Another day, another dollar. Okay, guys. So today, let us apply what we have learned. Okay, so you guys should remember that the first thing before I started this lesson, I taught you guys about prime numbers. Okay, so you will see they are very important. Okay, we are just going to use them right now. Okay, so these are prime numbers. Remember that prime numbers 2, 3, 5, 7 and 11. Okay, so and then remember that the prime numbers are those numbers that can be divided by itself and one only. Okay, so we mean that without leaving a remainder. Okay, cool. So you also need to remember your definitions or your laws. Firstly, let's remember the laws. Okay, if you multiply the powers that have the same basis, okay, so a and a exponent m, all of it we call it a power, right? But then a, it is a base, and then m, it is an exponent. And then we say that if you multiply the powers of the same base, you just take one base to represent those two bases, and you add the exponent being m plus n. Okay, guys. And then we said that that does not apply when you add the powers of the same bases. We do not have a rule for that. Okay, guys. And then we said that when we divide the powers of the same base, you just take one base to represent those two bases that you are dividing, which are the same, and then you subtract the exponent. And then please be very careful when you subtract the exponent. You take the exponent of a numerator, subtract the exponent of a denominator. Okay, and then we said that please be careful that you do not fall into a trap of saying that a exponent m minus a exponent n. Apply the rule that says that when you divide the powers of the same base, subtract the exponent. So here you are not going to subtract exponent. So as much as we are concerned, but then we do not have a rule for that. Okay, and then law number 3 and law number 4. Okay, so let us just take an example and apply these things. Okay, so provided that you are given, let's take some example. So example number 1, let us say that you are given a 2a squared times, I'm really sorry about that, guys, times 3a cube times b exponent 0. Okay, so we are simply going to apply our rules. Okay, guys, so I'm just going to try to be as slow as I can so that you guys can hear me. Okay, so what's happening here? These dots, remember that they mean multiplication. Okay, so the first thing that I'm going to do, I'm going to multiply the numbers 2 times 3 times 1. We assume that there's 1 here. 2 times 3 times 1, it is 6. Okay, this one, it is for the numbers. Okay, and then again, you notice that you have a squared times a cube. Okay, so here you are multiplying the powers of the same base. So we said that whenever you multiply the powers of the same base, just take one base to represent those two bases and add the exponent 2 plus 3, like that. Okay, and then times this b exponent 0. We had a rule earlier on, or a law saying that, or a definition. Yes, it was a definition. We said anything to exponent 0, it is 1. Okay, then your answer will simply be 6a 2 plus 3, it is the same as 5, times 1. And then this thing, it is the same as 6 a exponent 5. Okay, let's do b. You have 3 exponent 5 times 3 times 3 exponent 3, all of them divided by 3 squared times 3 exponent 6. Okay, so now here we can simply say that this thing, it is the same as, if you check here at the top, we are multiplying, and then even down there we are multiplying. Okay, so you are allowed to say that you are multiplying the powers of the same base, and then when you multiply the powers of the same base, you can just take one base to represent all those bases and then add the exponent. So the exponent, you are going to say 5 plus, you see here, if there's nothing, we assume that it's 1 plus 3. Okay, so there's 3 there, and then divide by. Now for denominators, we are going to take 3 to represent those two bases, and we say that 2 plus 6. Okay, then this will simplify to 3 exponent 5 plus 1, it is 6. 6 plus 3, it is 9. All divided by 2 plus 6, it is 8. Okay, then now dividing, you see, you are dividing the powers of the same base. When you divide the powers of the same base, you can subtract the exponent, or you subtract the exponents. Okay, 3, 9 subtract 8. Remember, it is always the exponent of the numerator subtract of the denominator. 9 subtract 8. Oh Jesus, my pen doesn't want to write here. I don't know what's wrong. 9 minus 8. I don't know, guys. Okay, let me just try to 3 exponent 9 minus 8. Okay, and then we know that the answer, it is 3 exponent 1, which is the same as 3. Okay, let's go to C. C. So on C we have this minus 3a cube b, all of them squared. Okay, a exponent 5 b cube. Okay guys, let's see how we're going to deal with this one. Okay, so I would advise you guys to first remove the the brackets. Okay, so it means that we are going to square everything in the brackets because of this square. Everything is in the bracket, and then that square is outside. Okay, so when you say minus squared, so minus squared, guys, it is the same as say minus times minus. Okay, that's minus squared. So minus squared, we know that it is positive, right? So we're not gonna write that positive. And then 3 squared, right? And then a to the power 3 times 2 and b to the power 2. So what we basically did, guys, we distributed this 2 to everything that is in the bracket. Hope you notice that. And now we are just going to say that a exponent 5, b exponent 3. Okay, then let us simplify this. And then from here we can say that 3 squared, you can press your calculator, 3 squared, it is 9. Okay, and then that one is going to be a exponent 3 times 2, it's 6. B squared, all of them divided by a exponent 5 b cube. Okay guys, and then this will simplify to 9, right? And then a exponent 6 divided by a exponent 5. You are dividing the powers of the same base. Then what do? You subtract the exponent. 6 minus 5 times b exponent 2 times, b exponent 2 divided by b exponent 3, it is b exponent 2 subtract 3, it is minus 1. Right? Remember that we say that an exponent of a numerator subtract an exponent of a denominator. Okay, so 9 a exponent 6 minus 5, it is 1, so we can just leave it like that. B exponent minus 1, remember we apply that rule of ours. Okay, so this minus will become a fraction, and then this b will go there to be a denominator, and then that one you can just put it there, but then it's not important. Okay, and then we make it 1. We use 1 to make it a fraction. Okay, then this thing, when you simplify it, you can say 9a times 1 over b, meaning that this and that do not cancel. We cannot cross cancel because of there are no factors that there are no numbers that can cancel. Okay, 9a times 1, it is 9a divided by b, and that's your answer. Okay, so the last one, for example 1, D. So here we have 2x cube all divided by 8y exponent minus 4, close the bracket, exponent minus 3. Okay, so you will notice that everything, it is inside the bracket. It is within everything. It is within the brackets. So meaning that everything, it is going to be affected by minus 3. Okay, so let us distribute that minus 3 to everything. Then it's going to be 2 exponent minus 3, right? Times x exponent 3 times minus 3. All of them divided by. Remember, guys, I advised you that whenever you are dealing with bases, make sure that those bases are what? They are prime numbers, okay? 8. Okay, 8 is not a prime number, guys, because of 8 can be divided by 2, can be divided by 1, can be divided by 4, and can also be divided by 8. So it is not only divisible by itself and 1. Okay, so we must change this 8 to a prime number. So this is how you can also use your calculator. So you just press 8 on your calculator, followed by equal sign, right? And then followed by shift, and then followed by a knob which is written fact. Okay, you will look for it on your calculator, and this will give you 2 exponent 3. Okay, so 2 exponent 3, this base 2, it is a prime number. Okay, so 2 exponent 3, and then y exponent minus 4. Okay, so cool. So now let us simplify this. So what's really gonna happen here, it's that for this part, this portion, this side, okay, let me just draw a box for this portion that I'm talking about. Okay, for that portion, you are dividing the powers of the same base, and then you are allowed to say that 2 exponent minus 3 times x exponent minus 9, right? Because if I said the 3 times minus 3, all divided by y exponent minus 4. Okay, I hope we're still together, guys. And then this one is going to be 2 exponent minus 6, right? You minus 3 and minus 3 will give you minus 6 times. Now this one, x exponent minus 9 divided by y exponent minus 4. Okay, then we are going to say that 2 exponent minus 6, guys, it is the same as this minus becomes a fraction. Are we together? Yes. And then this 2 become your base, and then this 6 will be your exponent, right? And then you just put 1. Always you put that 1 to make it a fraction, times this minus will become a fraction line. This x will become your denominator. That 9 will be attached directly to x, and then you just put 1 to make it a fraction. Divide, right? This minus will become a fraction line, and then this y will become your base as a denominator, and that 4 will become exponent, and you just put 1 there to make the fraction. And now one last thing, 1 exponent 2 over 6 just write it the same way as it is, 1 over x exponent 9. Then this divide, remember I said that if we have divisions of, here we have a division of a fraction, and then here we have a divide symbol, and then here we have a fraction, so we can change this one to make it a multiplication. So when we change it to be a multiplication, then we must change the order in the side. The denominator will become a numerator, and a numerator will become a denominator. Okay, then your answer will be simply 2 exponent 6. It is the same as 2 times 2 times 2 times 2 times 2 times 2. Okay, so 2 times 2 times 2 times 2, 2 times 2, it is 4. 4 times 2, it is 8. 8 times 2, what is 8 times 2? It is 16. 16 times 2, it is 32. 32 times 2, it is 64. Okay, so 2 exponent 6 will give us 1 over 64. Okay, and then times that 1 times that y exponent 4, and then x exponent 9, like that. Okay, so basically what I did, I just multiplied all our numerators. 1 times 1 times y exponent 4, they give you y exponent 4, or 1y exponent 4. 2 exponent 6 times x exponent 9 times 1, this is 1, eh? It gives you 64x exponent 9, and that's it. Thank you.